Okay. Can we prove that the quadrilateral is a parallelogram based on the given information? Well, we know that if opposite sides are congruent, then we have a parallelogram. And this says that opposite sides, for number 13, opposite sides are congruent. In fact, not only are opposite sides congruent, they're all congruent to each other. So this makes a special type of parallelogram, which is a rhombus. And if you're a rhombus, you're definitely a parallelogram. Not you, but if it is a rhombus, then it is a parallelogram because a rhombus is a special type of parallelogram. So yes. So let's just write, let's get that out of there and write yes. The quadrilateral is a rhombus and all rhombi. Gotta look that up and check and see if that's legit. Are parallelograms. Rhombuses, I think you could say. Okay. Whoops. So then for number 14, is this enough information? Let's see. We know that one diagonal is bisected. Do we know this other diagonal is bisected? We don't actually. And so, excuse me, we could have a situation where, let's say, this side and this side stuck out in such a way that that was not equal to that. Okay, so we need to have both sets of diagonals, and then we could say no, both diagonals are not necessarily bisected. The reason that we say not necessarily is because we don't know that those two segments, this segment and this segment, we don't know that they're not equal. We don't know that they are, so we just don't know. So we don't have enough information. And for number 15, is this enough information? Yes. If both pairs of opposite angles are congruent, the figure, the quadrilateral specifically, sorry, I'm running out of space here. You can't see it, but I have buttons on that side, is a parallelogram. Sometimes if you see me acting funny and glitching out, it's because I've got controls that are blocking part of the screen and you just can't tell that. So yes, if both pairs of opposite angles are congruent, the quadrilateral is a parallelogram. So 13 and 15, yes. 14, no, not necessarily. And what they're asking for yes or no is, can you prove it based on the information? And no, I can't prove it. Can't say no, it's not. I just can't.